So the topic that we are going to cover today is gonna be square and square root. Okay. So as we have already discussed, then when we are multiplying the same number by itself for the multiple number of a time or for a single time or for what we can say for more than one time. Okay. So that concept in mathematics is known as square. Okay. That is known as what we are finding. We are finding the square of any number. Okay. That is gonna be a power and exponent. What you said, Gitesh, that was absolutely correct. Now, related to that, if I'm asking that I have one number which is 3, okay? Now I am multiplying 3 for 2 times, okay? So what I can say that instead of writing like 3 times 3, I can write it in any other way. Yes, anybody? Yes,
Ma'am, it could
Gitesh.
be 3 square, ma'am. It could be 3 square.
That is gonna be 3 square. Correct. I can write 3 times 3 as 3 square. Correct. So what is this? So this power 2 is basically known as square. Okay. If I am multiplying any number by itself, okay, so that means I am finding the square of that particular number. Got it? Okay. So here, if I'm finding the 3 square, so that means 3 times 3, I am getting 9. Okay. And instead of writing this 3 times 3, I can write 3 square as well. Got it? Now here this 3 is gonna be base. And this 2, what I have written over here is gonna be power of that particular number. Correct? So if I need to write this whole, if I need to read this whole concept, so I can read it like 3 raised to the power 2 or 3 square. Got it? Okay. So from this, what we can conclude, if we are multiplying any number for the 2 times, or if we are multiplying any number by itself, that means we are finding the square of that number. Got it? So similarly, square of 1 is gonna be 1, square of 2 is gonna be 2, which means 2 times 2. Square of 3 is gonna be 9, which means 3 times 3. Square of 4 is gonna be 16, which means 4 times 4. Like that, square of 28 is gonna be 784, which is 28 times 28. Got it? Got it? Now, what is the meaning of square? Yes? Okay. Now, so here what we can see, if I'm finding the square of 3, I can say that the square of 3 is gonna be 9. So can you just tell me what this 9 is known as? Yes, Candy, can you tell me that what this 9 is known as? If I'm finding the square of 3, I'm getting 9. Okay. So this, the 9, what I'm getting after multiplying 3 by 3. So this 9 is known as what?
3 squared.
Sorry?
3 squared.
This square. Yes. So 9, what I can say, 9 is a perfect square number. Got it? And what this 3 is known as? I'm finding the square of 3, which is 9. So 9 is gonna be a perfect square number. Now, what is this 3? In the relation of 9. Yes? Gitesh, any clue? Gitesh and Kumar?
Ma'am, it could be the square root.
Absolutely correct. So this 3 is known as square root of 9. Okay? This 3 is known as square root of 9. So what we can say, the square of 3 is 9 and 9 is a perfect square and 3 is a square root of 9. Okay, now to represent square root, how I will write it? I will write it like 9. The square root of 9 is gonna be 3. Got it? Okay, whenever we are putting this symbols to any number, so this symbol means square root. Okay, And the square root of 9 is what? 3. Square root of 16 is what? That is gonna be, yes. What is the square root of 16?
Ma'am, it would be 4.
Very nice. If I'm asking that what is the square root of 36?
Ma'am, it would be 6.
Very nice. That would be 6 only. Okay. Now you know the concept of square, a perfect square number, or a square root. Yes. Now you know all the 3 terms. Okay. Okay. So let's move on. So now from this, what we have learned, so what we can conclude, whenever the number you are getting, when your number multiply by itself, so that number is known as a square number. So like 2 times 2, you are getting 4, 4 times 4, you are getting 16, 5 times 5, you are getting 25. So all these numbers are the square number only, okay? Okay. So here also we can relate perfect square with the square figure, what we have in a geometry, because in the geometry, square, geometrical shape square, all the sides are of a equal length. And whenever we need to find its area, what we are doing, we are multiplying side by side. Okay. And from here, we can get the concept of square. Now the question is, if, okay, so let's go behind. If I need to go back, so what I can say, if I'm finding the square of 1, I'm getting 1. If I'm finding the square of 2, I'm getting 4. If I'm finding the square of 3, I'm getting 9. If I'm finding the square of 4, I'm getting 16. Correct? If I'm finding the square of 5, I'm getting 25. If I'm finding the square of 6, I'm getting 36. If I'm finding the square of 7, I'm getting 49. Correct? So what I can conclude from this, if number ends with 1, so square ends with 1 only. Correct? If number ends with 2, so square ends with 4. If number ends with 3, square ends with 9. Here square ends with 6. Here square ends with 5. Here it is end with 6, and here it is 9. Okay, so what we can conclude, if number is ending with the digit 1, 4, 5, 6, and 9, then only we can say that the number, whatever is there, whatever is given to us, could be a perfect square. That number can be a perfect square. Okay. So the first condition for having a perfect square, for being a perfect square, is that the number should end with a digit 1, 4, 5, 6, and 9. Got it? If number is ending with the digit 2, 3, 7, and 8 at its unit place, so that number cannot be a perfect square of any number. Got it? Okay. This is the method through which we can find, without solving and without finding any perfect square, we can say that this particular number is a perfect square of any number or not. Got it? Okay. So now some properties are also there that we can keep in our mind when we are solving the perfect square or the squaring things. So whenever the number ends with 1 or 9, okay, so its square will always ends with 1. Okay, whenever the number ends with 1 or 9, so its square number, the last digit of the square has to be 1 only. If number is going to end with 2 or 8, so the square of that number going to add with a digit 4. Okay, now if number ends with 3 or 7, so the square of that number is going to add with the digit 9. Okay, now if the number is going to end with 4 or 6, so the square of that number is going to end with the digit 6. Got it? Have you got all these things? Any confusion till here? No? Okay. Okay. Now just tell me, if I'm asking you, okay, before going on this slide, if I'm asking that if particular even number is there, suppose your number is gonna be, what I can say, 12. Okay. If I'm finding the square of an even number, so what will be the square of that number? That number will be even or odd? Yes,
Ma'am, it would be even. It would be
it
even.
would be even. Okay, if I'm finding the square of any odd number, then it would be
Ma'am, it would be odd.
It would be odd. Correct? So what we can say, if your number is odd, then if your number is even, then its square is also gonna be even. Got it? If your number is odd, then its square is also gonna be odd. If your number is even, then its square is also gonna be even number. Okay? That is the property that we need to keep in mind when we are solving the square and square root of any number. Okay? Now, the other thing is how many number of the zeros should be there in the square of any perfect number. Okay? So if your say if I'm finding the square of 90, so the square of 9 is what? That is 81. And since 90 includes the number of 0 as 1 only, okay? So in the square of 8, the number of zeros become 2. Okay? If it is having 2 zeros, so in its square, the number of zeros becomes 4. Okay? So every time in the square number, the number of zeros has to be an even number. Okay? Got it? Okay? So in 30, there is only 1 0. So that's why in the square of 30, there are 2 zeros. If there is 3 zeros, so in the square of 5000, there should be 6 zeros. If there are 2 zeros, so in the square of that, there should be 4 zeros. Okay? Like that, the pattern continues. Got it, everybody? Yes? Now, if I'm asking that without calculating, can you tell me that how many numbers lying between the square of 3 and 4? Without calculating, without actually finding, just tell me that how many numbers lie between the square of 3 and the square of 4. Yes? Candy, Gitesh, Kumar, anybody? Any clue?
Ma'am, I can calculate it and do, but without doing it, I can't get it, ma'am.
So simply what we are doing, what we can do, like the square of 3 is gonna be 9 and the square of 4 is gonna be 16. So we can simply find that how many digits are, how many numbers are lying between 9 and 16, correct? So this method we can apply when we are having a small number of digits. But this we can't apply when we have a large number of digits. We cannot apply this thing over there because it will take a lot of time. Okay. So for this, we are having one formula which is known as and. The capital N denotes the bigger number minus 1. And then we need to subtract a small n, which is a smaller number. Okay, let's try this formula. So we need to find the number, how many numbers lying between the square of 3 and 4. So the square of 3 is 9, the square of 4 is 16. So here the bigger number is 16, the smaller number is 9. Correct? So what we will do, 16 minus 1, which is 15, and from this 15, we will subtract the smaller number, which is 9. Okay, so 15 minus 9 is gonna be what? That is gonna be 6. Okay, so between the square of 3 and the square of 4, there are 6 more numbers. Got it? Yes, understood? All three of you? Candy, Gitesh and Kumar, understood? Okay. Now, so do you know that what is the Pythagoras theorem? Have you ever heard about it?
Yes.
Yes, so what
Yes,
is that?
It's a theorem where hypotenuse is equal to the square of other two sides.
Correct. So Pythagoras theorem states that the square of hypotenuse is equals to the square, the sum of the squares of other two sides. Correct.
Yes.
And here also, if you notice, we are finding the square of every three sides of the triangle. Okay. And this property applies on right angle triangle only. Correct. So related to that and same like that, we have Pythagorean triplets in square and square roots. Okay. So what is that Pythagorean triplet? So that is, if we have three numbers, suppose we have 3, 4, and 5. Okay. So what is okay, what should be there? If I'm finding the square of 3 and the square of 4 and the square of 5. So a square of 3 is 9, a square of 4 is 16, and a square of 5 is 25.
Right.
Okay. So if I'm adding the square of any two number, like the smaller number, so that should equal to the square of the biggest number, whatever is there. Okay. So that makes a Pythagorean triplet. Okay. So for making the Pythagorean triplet, we have one formula and we have three members of that. That is gonna be 2m. Next is gonna be m square minus 1, and third one has to be m square plus 1. Okay, so these are the three members of Pythagorean triplet. Okay, if one of the member is given to us from these three, we can find the other two numbers as well. Okay, suppose from the Pythagorean triplet, the smallest number is given to us here, which is 12. Okay, so what we can do, we can put this 12 equals to 2m. From here, we can find the value of m, which is 6. Okay, now we can put the value of this 6 in m square 1 and m square plus 1. Then we can find the value of rest two members of this Pythagorean triplet. Correct? Similarly, we have another example over here. So Pythagorean triplet is there whose number is 5. Now we need to check that can we put 5 equals to 2m or m square 1 or m square plus 1. Okay, so we can put 5 equals to m square plus 1. When we are solving it, so we are getting m square is equals to 5 minus 1. So the value of m square becomes 4, and 4 is a square of 2. So we can take the value of m as 2. Correct? Now we can put the value of m over here. So we are getting 4 over here. And from here, we are getting 4 minus 1, which is 3. Okay. So what Pythagoras triplet we can form over here? So we can form 3, 4, and 5. Got it? Now got it? What is the Pythagorean triplet?
Yes.
Yes? Okay.
Yes.
Now after that, we have one more thing that we need to cover over here about the prime factorization. I think that you all know about prime factorization, correct? So we can
Yes.
find the square root of any perfect square number by prime factorization also. Okay. So suppose number 256. Okay, and we need to find the square root of 256. So for that, what we can do, we can find the prime factorization of 256, which is these time 2. Okay, so now we need to make a pair of 2. Okay, and from each and every pair, we can bring 1, 2 outside. Okay, so now how many 2s are there? 1, 2, 3, 4. So we can multiply every 2 by itself. Okay, so what we can say, this 256 is a square of 16. Got it? So through this
I have a
concept,
question.
yes, sorry.
What if there is one extra 2 which doesn't come in a pair?
No, I think every 2 has been covered over there. Okay, let me show you. Okay, so see, this is one pair, this is another pair, this is another pair, and this is another pair. Now no 2 is left behind.
What if there was another extra 2? That's my question.
Okay, what if there is an extra 2? Okay, so that number is not gonna be a perfect square. Suppose in 256, okay, we are suppose any number is there, and here we are getting an extra 2. Okay, so that number, whatever is given to us, that is not a perfect square of any number. Okay,
Oh,
now,
okay.
so for making that number a perfect square, what we can do? We can multiply that number by an extra 2. Okay, if we are multiplying that number by extra 2, so now we can make a pair and that number becomes an perfect square.
Ma'am.
Yes.
So 512 is not a perfect square, no, ma'am?
Yes, 512 is not a perfect square.
Okay, ma'am. But
Yes,
1
because 256 times 2, we are getting 512, and 512 is not a perfect square. If we are multiplying this 512 by another 2, so what we are getting?
Will be a
We are
perfect
getting
square.
1024 and this 1024 becomes an perfect square.
Ma'am, I have another doubt, ma'am.
Yes, yes.
Ma'am, so at the place of 2, like if it is not able from 2, then we can go for 3 also, no, ma'am?
Yes, if an extra
So
number
that
over there is 3, then we can go with 3 as well.
in 3 also we should make 2 pairs and multiply
Yes.
those 3.
Yes, yes, yes.
Then if
Yeah,
it would be multiplied by 3, that would be 27. So 3 raised to the power 27, that would be.
I'm not getting what are you asking?
Ma'am, for
Yes.
example, ma'am, we took
Yeah.
a number, ma'am. In that, the 3 pair we made, ma'am. So the pair that were made were 3. So that
Okay.
would be 3 multiplied 3.
Correct. That is 27.
Is equal to 27. So it would be 3 raised to the power 27.
Why 3 raised to the power 27? No.
27
what?
raised to the power of
What are
3.
you saying? What are you saying? Suppose any number is there. And instead of these 2's, we are getting 3 like that. Okay. And
Okay.
from those 3, we can make 3 pair of 3's. Correct?
Yes,
That
ma'am.
you are saying?
Yes,
Correct?
ma'am.
Now, from this, what we can say that from this, 1 3 is outside, 1 3 will come outside, 1 3 will come outside. And
Okay.
here we are getting 3 times 3, which is 27. Okay.
27.
So whatever the number is here, that is a perfect square of 27. Okay.
Okay.
That is
So
a
that
perfect square of 27. Which
Okay.
means we are going to put a square on 27. So the number what we are getting, that has to be the square of 27.
Okay. That number is equal to x. So
Correct, correct.
okay.
Okay, we are not going to put 27 in at the place of power. Okay, so that number 27 is the square root of that number. Understood?
Yes.
Okay. Now we are going to take some examples. Okay. So now here one number is there. We need to check that which of the following perfect square number is the square of an odd number. Now out of the given option, which one is the perfect square of an odd number?
Ma'am, it would be A, ma'am.
It would be 8 because the option A
Ma'am,
is ends with an odd number. That's why it would be A only. Now out of the given option, which is the square of an even number?
Ma'am, it would be C, ma'am.
Correct. It should
C.
be C only. Now how many natural number lie between the square of 11 and 12? So we will use that formula only, n minus 1 minus a small number. Okay.
Ma'am, it would be B, ma'am.
Sorry, it would be
B, ma'am. 23.
let's solve it. The square of 11 is 121. The square of 12 is 144. Okay. And when we are going to solve it like 144 minus 1, we are getting 143. And 143 minus 121, what we are getting?
Oh, okay.
We are getting 22. So that has to be 22 only. Yes, Geetesh?
Yes, ma'am, I understood.
Okay. Now just tell me, what is the unit digit of the square of 564? If we are
Ma'am, it would
finding
be
the
8.
square of
Option C,
564,
ma'am. Option C, ma'am.
No, it can't be 8.
Okay, I'm
What we have learned, what is the square of 4?
I think it's B.
16.
That is 16 only. And what is the unit place digit of 16?
Unit place is 6.
6 only. So the square of 564 also ends with the digit 6. Understood? Got it?
Yes.
Yes?
Ma'am, can you explain it again?
Okay. Now, suppose if any number is there, suppose your number is 239. And if I'm asking that without solving the proper square of that number, just tell me that what is the unit place digit of the square of this number. Okay, so what will you do? Now just tell me that what is the unit digit of 239?
39. It will be
9
8.
only.
8.
Now
8.
what is
8.
the square of 9?
81.
81.
It's one.
What is the unit digit of 81? That is 1.
One.
So the square of this number also ends with 1 only.
I understood, ma'am.
Okay, ma'am.
Understood? Suppose if any number is there like that. Okay, so what is the unit place digit of this square?
Ma'am, it would be 4, ma'am. So it
Yes.
would be 8 or 2.
Yes, it could be yes. So for the square root, it could be 2 or it could be 8. Yes. Yes, that we can conclude from here. Okay? Understood now? Any problem till here? Anybody?
No.
No?